Okay. So one we have 9 to pick from. 99, 91, 91, 00, 99, 01, 991, 001, 991, 0019, 10019, nine. Right, so have at least three number. So basically we can pick any of these number. Right, it will be 199 and so on. So now the sum gonna be 10. So 10, the next one we expect is has to be 9. Right, so this one we expect 100. So we take 1 9. We just keep expanding the tree, right? It's like a okay. Okay. So so in the pick you also need to know leading 0, the picking point, right? So of course these will have, I would just pick one. I can just do 19, right? Starting with 19 and so on, and 199, right? So basically what we should do is we get string. Okay, so basically gonna be We will start with like an array of 1, 19, right? 199, so on. 99, 991. Oh, oh, one 19, 199. So 1991, 1991, oh, 1991. So the number is this. One nine 100. Okay. 199 1001, right? Nine. This one. So that is picking starting at 1, right? What about starting at 2? 99, 9, 99. Right? Don't you just generate all the numbers? 999, 991, 9910. So basically it is all of these number except we ship them. We ship the number out. So 999 ship the number 1 out, right? And so on. Keep shifting, right? So that is the problem space. So until we get to what? The last 9. Right. Of course, somewhere along here, check size. Can pick more than 3, right? Something like that. So yeah, we started with 1. Started with this. So let's start it with every number, right? So we we expand the space later. Characters for characters in what was that? Num. Right, so why still have something to do? We basically do a depth first search. Let's do that. So basically now digit equal q dot pop, the first one, right? If b is basically we say that if length of d is less than 2, then we keep expanding. If less than 2 or the is less than 2 or the condition, let's just do condition math here, then we expand it, right? Oh, so this is actually should be an array here, right? Because we need to know what is the size of this, right? Okay, so let's just do if length is less than 2, then we just expanding, right? We also need to know probably the index, right? I for IC. So let's keep track of the index. And here is the thing here. Wait, actually, yeah. Index array of IC for IC in what is it? Enumerate. Right, so this is gonna be an array of digit if length less than that. Good. So then from this index we basically look to the right here, and then we get every element of size 1, size 2, size 3, or whatever, right? We might also want to quickly check the current size of the, let me see what, each subsequent number in the sequence must be the sum of preceding 2. So we can find if less than 2, right? So here let's take a note, keep picking the next element. Okay, for I in range starting at the last character, and we do so from 1 we can pick 99, 991, 991, 10, and so on, right? So for I in range of this, starting, so we need to find the index here, right? Starting at the bi the last one, first element plus 1 to the length of num, right? So basically we want q plus equal, no, we want okay, so basically choices go to choices 10 to bi num I, right? So basically q equal to choices plus q, right? Okay, now if the length go to 2 or more, oh, 3, sorry, it's less than 3, okay, else then we need to, now it has 3 number, right, except the first 2. Oh, okay, 2. If it's less than 2, then edit. So now if it's less than 2, if we go to 2 now, right? So now we have to pick only the one that make that equal the sum of previous 2, right? So similar to here we have, right, from here what we want to do is if num I equal to the previous 2, minus at this is minus 1, we have convert them to integer, actually in this, right? If yeah plus int of p minus 1, no, minus 2 minus 1, then only then do we get this number, and right, so and when did we, so if d of 0 is greater than, it's like if we so di plus length of starting at that index plus the length of the d minus 1 is basically greater than length of nums. We found the result, right? Return true. I guess here's when we return false. Something like that. Try it out. Oh. This is tuple. Oh, d0, sorry, d0 minus 1. Okay. Okay, so first let's print our stuff here. We have basically this array. Take 0, yeah, take 1, take 2, take 3, take 4, 5, right? And then what is our choices here? Let's print it out. Some choice here. You didn't even get the choices. Okay. If D, when we pop this, let's print D here. D is an array, right? Okay, it's an array. Oh, 0, 0 here. Oh, num.s. Okay, so choices for the one is 1 1 2. Oh, okay, so another thing we need to do is okay, this is actually d0 minus 1 plus this. This is also d0 minus 1 plus this. Right, so what happened now? In object is not subscriptable. Where? What do you mean? Oh, this has to be a tuple. Too many here, guys. And a tuple, right? There we go. So choices, we take 11. Wait, so here we do here. Oh, this has to be an array here. Because like we said, we're starting at 1. Wait, hold on. Let me think. So we pick a number here. The choices will be this many. This 99, whatever, right? Then if we pick 1, then our index gonna be this. And do we just need to store the one plus 99 is 100, right? So we just need to store the sum, right? So writing so now we are at 100. So first we have 1 and 99. That will make us become 0, 1, 2. It's index 2. When we are at index 2, we need to find the number 100, right? So basically this can be -1 basically. So this will be let's just write down here in last index, and C here will be expected number, right? So when we do right, the string down to index 0, we don't expect anything yet because we make a negative. So basically we here call it I, expected num, right? So we say if I, so basically this had to change to I greater than or equal to length of num, then we found it. Otherwise we say that if expected num is -1, then we pick the choices, and basically we start at I plus 1 to the end of the length. We added hello, what's up? Sahil Lande, what is going on from YouTube? Start here, we just append and so now the big question is when the element two sides, right? How do we do that? Oh, we can do another thing to help us here. Will be 0. and basically we say here is the element, right? So after we append here, we do let's just call this element, so let's just call it sc size be sz plus 1, right? And basically all the sum here will be, we started with the letter I, integer of c, right? So first we know if the depth is less than 2, right? Then plus this, and this will become expected num plus the integer of num I, right? So that is what it is. And then when it's do that, then we also do loop from, feel like we can make this become like 1 somehow, okay? So we also do this, right? So now we check if the num equal to expected num here, then we pick that. And so now let's say we go to 99, right? So we expect 100, right? So do we also, what is it, someone bring me something, 1 second, let me check my phone. I'll have to follow up with some of the link that they sent here. But where are we? So we expect 100, we found 100, and we want to expect 99, right? So that means that we should probably store the last number, right? Will be C as well, right? So this will always be the last number in num I. Be previous number Bn, right? So yeah, so we want if the one that if it is when it is side 2 already, right? So and then we expected when side 2 we expect 100, okay? We found 100. When we found 100, we want a plus z plus 1, and we want added the previous number gonna be now integer of num I, comma, and now the we expected gonna plus this one num I, right? So let's see. What? Oh. And too many parentheses here. Right? So this is close that. Close this. Close that, right? Maybe it's not the file. So we print I, size, en, expected number. Okay, so let's just do this. Let's print them out. What if we messed up? Okay. Oh, we forgot to convert them to integer here. Return false. Choices. What? So previous number. Let's just start with DC printing here. So right now previous number is 1, 3, okay. Oh, let's look at our case here because we do the example that 1, 9, right? We expect 10, right? And then previous number 9, we pick 9, we expect 19. Right, let me write down. We got 1, 9. We expect 10, right? And we found 10. Why is this wrong here? $199. Do we ever get to $199? No. What did we do wrong? Print. Right. So if size is less than 2, right? Just print the choice here, whatever. See if it's correct. All about printing. Okay. The previous number is 1, right? So 1 here. And expected number, it doesn't matter first. Then we pick 9, right? And then we expect 10. So we pick 9. Right. So does it have to be consecutive? So now we have 1, 9. We expect 10. When we expect 10, so the 10 case will fail, right? Because it will pick 10 here. Couldn't find 10. So we back up and then we expect 100, right? So we should pick 99. So something is wrong here, right? So if we pick 9, we expect 10 here. In choices is yeah, we couldn't find choice, right? So now 9, 9, 10. We couldn't find choices, right? What? Why there's still choice here? Something is wrong here. Gonna be hairy debugging. Okay, hello, hello. Okay, mute the mic. Mute. Okay, so I was debugging. As long as it is 2, we just pick from less than 2. We pick from, so let's say 1. We have 9. We have 99. Oh, I did something wrong here. This is just pick one number, right? This has to be 9 and 99, right? So this is gonna be start of this instead of this. Gonna need a j equal I here. J equal I here. We'll start from here to here, and then it's gonna be j here, right? And it's gonna be number of, so the digit gonna be num of starting at j, right, to j equals there. So it's starting from j to whatever, right? And you have to take j to I plus 1, right? So this will be integer. So this will be D, and expect num plus D, right? Similar here. Right, so this will be, number will be, so basically we save the first one and then why not, let's do this, let's change this to, so we need to start from this index to the end, but every time we go, the number gonna be from the beginning to that number, right? So we're gonna do, so here we're gonna do is we're gonna do J in, we can start at the second index, every letter, so the start here gonna be I plus 1, right? So we're starting with this, and every time we go, we start with I plus 1 to that number. So we loop from that index, that new index, to the end, but every time let me do one thing real quick. So we have an array 9, 99, 991, we pick one, 9991. Oh, why don't we do this? So we have basically the string will be this, right? So basically we loop from I plus 1, right? And S will be plus equal, what is num I, right? Right, so here it's gonna be integer up S, and yep, that seems better. So here we also do the same thing. Okay. Plus 1. So if we found a number, then we basically integer S plus integer S, right? Okay. The previous number is 1, whatever, right? Choices. Oh. Wait a minute. Integer S. No. Yeah. Okay, so let's see. We pick 1. What is I? Previous number is 2. Okay. So do we see 199? Ah, why does it pick wrong here? Okay, hold on. So previous number is basically num j. I here is I'm sharing with this I already. Num j. That's the first thing. And this is j. Right. If num j equal to if the number we pick, which basically integer of s here, equal to the expected number, then we do that. Let's print first. Okay, so this looks good. Okay, choices is 9, expect 10. Okay, 1, we pick 1. Choices is 9, 99, 991, 991, 10, whatever, 991, 100. Yep. So then we pick 9. When we pick 9, we expected 10, and we shouldn't be able to figure out the choices, right? Yep. So now we pick 99, right? Then we expect 100, right? Pick 99, we expect 100. Do we see 100 in here? Why do we not see 100? So we pick 99, right? What is the index here? Actually, let's print the index as well. I okay. 0 1 2 0 1 2. Okay, that was the last character of the 99. So our choices here is gonna be starting at J here, right? Let's see. Right. Okay, hold on. So when we get to 299 right here, we expect 100. We did not see 100. Why? Right, so index 2, we start at 1. So we got 1 and we got 0, 99 and it 0 1 2. So now we start, we're gonna have 1, 10, 100, 101, 199, whatever, and so on, right? So something is wrong here, right? So the last number here is also wrong, right? Isn't the last number, if we pick 99, it should be 99, right? So the we get is wrong somehow. So okay, so first is index, last number, and expect. Index is 1, okay. Oh, no, index is 2. Good. And we expect 100. Okay. And then 0, 1, 2. Yeah. So we should look from 3 to the end, right? So what is the I here? Looking from I plus 1 to len num. Right. You see? So for the choice that is 299. 299. What? Did this truncate the stuff? Oh, it's K2. Wait, print here somehow. Okay, let's print out the size here. And we have 199. Okay, why is it 1? Go at 1, 2. We already picked 99, right? Last number is 99. Oh, it should start at 1. Okay, fine. Okay. So we see if it picked the 9900. Okay. Okay. Looking from 3 to the end, right? So candidate is 100. Okay, right here. 100. Right. So it go from 0, 1, 2, 3. 0, 1, 2, 3, 4, 5. So this is the end, right? And we expect 200, right? 199, right? So something is wrong with expected num here will be previous number plus this, right? Not the I feel like it should be the same now. Right, okay, so we expect 199. Okay, so did we find 199? So 5. We look from 6 to 9. Choices are 8, 4. Yeah, we got 199. Okay, so when we got 199, the index is at 8. Right, so it could be greater than or equal to num. It does, right? So what is the length of num here? Nine. So okay, so if the next thing we look up, actually it was 1, because the next character we look at is actually there's nothing left, and it's found, right? Whew. Let's see if it passing. water. Submit, let's see. Oh, 0. Oh, use test day. So what do we have for this? Oh, that means, okay, so we need to print our queue here. I'm pretty sure if the condition is also has to check, right? Submit too quickly, bruh. Okay, fine, dude. Oh, we need to check the leading 0k as well. Okay. But I think it's probably fine. Queue here is empty. What? Zero, 1. Okay. So does it not go in here? The length is 1, right? What is not returned? Oh, false. Oh. And basically size here has to be greater than at least 3 number, starting at 1. So we started at 1, 2, greater than 2, right? Okay. We take out all the print line. What's wrong with this case? Okay, let's write down 1, 0, 2, 3. So we pick 1. Oh, this is the leading 0 case, right? So when we pick, we have to not consider the case where it has leading 0. Right? So basically if s 0 equals 0, then we should just skip. Right? I hate doing this. We should unify these. Right? So basically, what we can do is we do this regardless, right? So let's say if the size is less than 2, then append. Otherwise we do the right. So elif, we do that. Comment this out. work first. What? Oh. Its size is a pen. If ellipse size is greater than 2, isn't that what we do here? Case 4 is done, but what's wrong here? The output false. Oh, we forgot to do this. Yeah, so the refactoring work, we can do this. So okay, should be no print. Submit again. Okay, getting close. On a 1. So let's debug with print this out. Basically, after this, we print the choices. Okay, so first, 101. You expect, so if we take 1, we cannot take 0. We cannot take 0. Okay, so if this is that, then basically we have to do is skip that, right? So we need to reset it. Now case 4 failed. Okay, hold on. Let's print it out and see. Okay. So for 101, the size already 1. Previous number is 0. Oh. Here as well. The number 0 could also be here. Is it? No. 0 is index. Why is the previous number got nothing? Wow. Size, the second number. Why is the previous number wrong here? Okay, so we can just do unify this one more. So we added one less line, right? You pass except the 5th one. Okay. So what's wrong here? So choices give us nothing, right? So the mysterious thing here is previous number here. Okay, so if we pick the first one, right, then we can only pick one, right? So this should be true. Wow, this is true indeed. So let me write down. So we have 101. Oh, we can pick 0, but basically we cannot. 0 as one number is correct. So if length of s is greater than 1 and the leading 0 is that, then we cannot pick that. Yes. Okay. So because 0 we can still pick. Let me write down problem of basically 101 here. It's like can pick 0 but as one number but not leading 0. Okay. So submit. See the how it is. More edge cases. Oh, this is because we output true. Because so let's see. I suspect the previous number is 0 here because we forgot to do the thing here. Maybe I don't know. Okay, 6. What is wrong here? Get some water. What's wrong with these cases? Okay. So we pick a 2. Oh, this is a size 3, and okay, previous number is pick 1 2. Like okay, this is because it got to the end. So previous number is the third one. So 1 2. So we have 0 1 1 1 1 2. The first thing is so can we do something like test cases? Instead of that, we at that it should work, right? So does that because of the leading 0? Yeah, this is because of the leading 0. Because I think we have to handle something here. And we say that see if we pick a 0 here, right? And size 1, previous number is 0 right here. So we can, if So we can pick 0. Okay, so let's do that. We go this for IC in enumerate num, right? So it would be like q plus equal to I1 in C. Number is equal to in C, right? So this will be D, right? The first thing we need to look at if, because this is the first character that we pick, we cannot pick 0, right? So in other words, like that. But we can pick from 1 here, right? And it's still true. So we cannot pick 0 here. We pick 1. Then after we pick 1, we have 1, and we have 11, 1, 1, 1, and 2. So as soon as we pick 1 here, we expect 2. We expect 2. After we pick the second one here, we have 11, 1, 1, 1, and 2. Right? So what's wrong here? So we do 1. Oh, the number we pick from here can only ever increasing. So 1, 1, 1, 1, 1, and 1, 1, 1, 2. Right? So we pick. So the previous number is 11. We pick 11. We pick, where did we pick 1? We pick 1, we fail, right? We pick 11. Right. So we pick 11, that means we expect 12. Yeah. From 11 here, we can only find 1, 11. Then we only have 1 and 12 left. So we pick 12, right? So 1, 11. Wait, hold on. Pick 1, 11. Hold on. Pick 1. You can have 11. 0, 1, 1. 0, 1, 1. 1, 1, 2. So we pick 1. Then we pick 11. Then we pick 12. Right? So that is correct. 1, 11, 12. Why is it wrong? Or is it because we have to start at the first one, and because the first one is 0, it should invalidate them, no? Well, why can't I? We look at the description again. Can I not start with Or is it saying that I can only start with 0, 0, 0, 1, 0, 2, right? Is that I cannot start arbitrarily from any of these, right? Okay, so maybe that's what they meant. So if that's the case, we can do if okay, hold on. We need to do similar thing here. So s equal to this, right? So let's see. Right, so we start from beginning to the end of the number. We say that if it's gonna be plus this equal this, and okay, so we don't care about this. Just append you dot append this. Append always gonna be 1. Right. Something like that. Okay, now everything broke. In this case, 6 is correct. Oh, hold on. Just be that, right? What did we do wrong? I and 1. Oh, so we do just put I here. But print out here first. We see what did we starting out with. What does it print? Empty. Empty. Wow. Okay, hold on. We must have done something wrong here. Ding. So we start at 1. Oh no. This is wrong. This will be this S right here will be basically num beginning to I plus 1, right? So basically we have 1 1 2 3 5 8, right? So we want 1 1 2 1 2 3, which is you're correct though, right? So why is it empty? Length is greater than that, and the first one equals 0. So let's just print S here. What happening? Yeah, so we have those numbers, and oh my god, lot of babysitting, print debugging. I think that should be it. Okay. Submit. Okay. What? Beat 100% does make 0 sense. Let me copy this. Low. Because there's probably no one doing this. Like what? Are you crazy? Shut up, Firefox. Screenshot. I don't believe you. What the hell? So another pitfall is this number is cannot start with arbitrary number. Has to be 0, 0, 1, 0, 1, 1, 0, 1, 1, 1, right, and so on, because 0 invalidate everything. It left only 0 left, which the loop will invalidate them. Right. Okay, so let's commit to GitHub and then study a little bit of cache. Okay, let's see. Text. Commit GitHub. Bring up our VS Code. Okay. Wow, that's a lot of troubleshooting. Okay, so now what is the number? Doesn't have it. Okay. So now Python and Python. The tip number. Time complexity is basically what? All up. And if we pick everything like 1 1 1 1 1 2 3 whatever nk and third, yeah, so I thought too, because you go down like 3 layer at a time, and the lateral also, yeah, whatever, it's fine. Complete them is fine. Okay, so now we look at description. How would you handle of a self-array with very large input integer? We do some kind of big int library. I thought Python take care of that. Nah, man, it's okay. Just like backtrack and some HK, I think. How is it going bad? So how would you handle an without overflow? We either use begin library, right? for Java or something like that, or I think Python already did that, right? Or we just do string adder, right? So like we do our number, like adding number using string, right? So actually let's go through see what Python does after this, after I commit to the history, I commit to GitHub. Let's see. This one take a num. We test what commit the history first. Let's see. B from so we do some branding here. Okay, and what does it split array into Fibonacci sequence? No. Oh, we forgot the runtime. I don't believe the runtime. It said I beat 100%, probably like nobody attempts or something. That's unbelievable. 1931, 50, 52. Okay, so let's look at how does Python handle big numbers. Do you write like your own like int library? Okay, let me change. How does Python handle big numbers? So they said in this one. Okay, so I thought Python handle all the big number, but maybe not. Well, maybe it is. Okay. From Guido van Rossum, the Python creator. So they implemented in C, right? Because it's implied here. Okay. It is apply Python implemented in C. When operation on short in doesn't fit into C long, they raise an error. So basically, so turns out it does replace both in into one in. When did they release this? Is there a date they release? Initially, two alternative implementations were proposed, one by each author, the PyIn types. Also, they have a union tag, okay, with union tag struct. Yeah, with union tag union. Right. They have a number here, and I guess somehow if the number is big, they bind the memory to this instead. So either long or like unsigned long, and whatever this is. Only the n minus one little bit of the long have any meaning. Top is always set. Only the n minus one. Oh, so they switch between these two, I guess, by checking the bit, okay? So checking this one. Only the n minus little bit of the long have any meaning. Top is always set. Okay, so this one and two different implementations. The existing short and long in type remain, but coefficient return a long in instead of raising overflow when the result cannot be represented as short in. A new type integer may be introduced that is abstract base type of switch. Both the int and long implementation types are subclassed. This is useful so that program can check integerness with a single test. Okay, so let's go with the method 2. Turning all arithmetic on short integer except the result cannot be represented as a short int. Yes, C code had to figure that out. So the int function will return short or long depending on the argument. In Python 3, the function long will call the function int. Before then, it will continue to force the result to be a long int, but otherwise work the same way as int. Okay. Transition. Okay. So basically, the long or int here is actually matter for the C backend, right? Basically everything is int. Okay. Okay. The difference only matter to the backend C in this case, or user Python is already the interpreter basically invisibly will switch to correct type for backend as needed, and user just need to use int, right? Python, right? Okay, so that is Python. Yeah, float is the hard one. Okay, I guess. Okay, so now let's go back to we were looking at cache stuff. The cache tree. Right. We was looking at cache incident at Twitter long time back. This is a collection of information on step 0 and step 1. I think we have this here. So this is like historical preservation. For future usage and understanding. There's a Cortez Industry former director VP who tell self-aggrandizing story about all the great things they did that, to put it mildly, frequently distort the truth. Wow, what a mouthful. It is a real feeling, not a good reason. When people whose strategy project have proven not to work or making it worse, where then give talk, write blog posts, to create a claim on Twitter claiming how much of a success this strategy was. That's fraud. Oh, okay. I already follow. Wow. Copy construct. Okay, we have to come back to this. Cindy Sirdahan. Unpopular opinion: unless you're just prototyping, you should aim to understand as close to 100% production code generated by LLM as all of it. The effective mental model are still important for humans to sustainably maintain and evolve a code base via prompting alone. In fact, now that code gen has been automated away, it frees up a lot of time to read more code than ever. Not just work project, but also open source project known for high code quality. Yeah, this is yeah, I do that sometimes. Okay, retweet this. Okay, go back to this article. Although there's nothing stopping IC from doing this, the most spread false story we see tend to come from people on the management track. Okay, in both cases, there's a kind of Grisham law of story in play, where incorrect story tend to win out over correct story. Okay. Also, incorrect story. So basically, fabrication for cloud tend rather than truth tend to get viral. Is that what it is? So basically, let's quote that. Incorrect story tend to win over. Okay. What is this? Grisham law. Bad money drive out good. Okay, that's a good quote. Bad money drives out good. The Grisham law. And even when making a genuine attempt to try to understand what happened, it turns out that knowledge is lost fairly quickly. For this and other incident analysis project we've done, links to document and tickets from the past few years tend to work, but older links are less likely to work, with the rare getting pretty close to 0% by the time we're looking at things from 2012. Sometimes people have things squirrel down away in lockdown document, email, but whatever, right? Requiring talking to a bunch of people who will, due to nature of human memory, keep you inconsistent story that we need to piece together. Oh, wow, there's a lot of quote. Reading postmortem. This is a quote article. Okay. Every time you restart a cache server, it's step 0. On a good day, you might have 95% success rate. Okay, so basically, Twitter use a fork of Memcache. So basically, cache failure number 1. This is the most common source of failure. Right, so the Twitter use a version of Memcache. That's number 2 here. Okay, Redis make it worse for Twitter. Redis is worse for Twitter. I think which is like interesting because Netflix actually use Redis over Memcache. And they do the Cassandra, right? Okay, go back. Cache server is a high throughput, low latency RPC server plus a library that manages data, memory and or disk and key value indices. For in-memory caches, the data management side should be able to easily outpace the RPC side. A naive in-memory key value library should be able to hit million query per second per core, whereas a naive RPC server that doesn't uses fake networking, batching, and or pipelining will have problems. So basically, cache simple technique can simple. And in our case, RPC server. High throughput. The data management side should be easy. Okay, so basically simple. High throughput. Low latency. Plus data loading, unloading. Okay. When skim performance are concerned, cache will frequently use sharded cluster. Okay. Then subject cache to constraint and pitfall of distributed system, but with less emphasis on synchronization issue than with other workloads, such as strongly consistent distributed base, due to the emphasis on performance. So typically pair with sharded cluster. Okay. So basically, because that exposed to distributed system failure. Okay. Basically, sharded cluster implying this is distributed system. Right. Cache failure mode. Interesting because when cache is used to serve a significant fraction of requests or fraction of the data, cache outages or even degradation can easily cause a total outage because an architecture designed with cache performance in mind will not and should not have backing DB store performance that is sufficient to keep the site up. Susceptible to underneath system. Basically kernel hardware. See. So basically this okay, the interaction between cache and to the system. We'll need to look at these tickets. For a few months, a significant fraction of user initiates changes. How long is this, bruh? Wow. But I think we'll be fine. Okay. see what happened with the incident. Okay, so this issue is user change there. User changes got reverted. Twitter was running a Rail app, no metrics, so they added instrumentation. Found that it's cache is the issue. So basically took what, 2 weeks to resolve. What's the issue? The second thing intended to this number of time key appear in multiple locations will retry multiple times before ejecting a host. So basically the Rail app have spawned like many worker, and if the worker is not responsive, it took down. IRQ. So some host is running some old BIOS version. Expensive health check. Okay. Someone from the kernel team had noticed this exact issue about 6 months earlier and tried to push the kernel config change that would fix the issue. Hmm. Two months. 2 months. So oh, they're running on bare metal. Hmm. Okay, did they really fix this? Wow. Yeah. So alright, I think I'm a bit hungry, but let's summarize this and have to eat. So basically hold down because of stay not updated version of hardware. Version firmware version. What does the fixed cache architecture to Okay, I'm gonna call it